So distributions, probability distributions. There are different types of distributions in probability, but here we are going to discuss a few probability distributions. They are binomial distribution, Poisson distribution, normal distribution. So we are going to discuss these three types of distributions. The first one is binomial, Poisson, normal. Already I said what is a distribution function and density function, everything we discussed. Out of these three, first two comes under discrete probability distributions. This one, continuous probability distribution. Discrete probability distributions and continuous probability distributions. So here, discrete means they are defined on discrete random variable. They have a discrete sample space like this. A sample space for tossing a coin, a sample space for throwing a die. These are all comes under binomial and Poisson. When it takes that n infinity value, PQ are very small, then we go for Poisson distribution. N is large and probabilities are very less, very small, then we prefer Poisson. You know about continuous, when instead of distribution we have density in a particular interval, then we go for normal distribution. So coming to the binomial distribution, what is a binomial distribution? So actually here, the binomial distribution is a distribution defined on Bernoulli trial. What is a Bernoulli trial? A trial which has only two possibilities. Probability of failure, probability of success. We name it like that. Probability of success in each trial is same. And the random experiment contains finite number of trials. Countable number of trials. On that type of trial, this binomial distribution is defined. For example, there are n trials. Out of n trials, the probability of success is P and probability of failure is Q. We are defining P as probability of success. Probability of success. Q as probability of failure. And we all know that the total probability value is 1. What I am saying, if a random experiment contains n trials, out of n trials, there is r trials which has probability of success. The probability of success has r trials. Then out of n trials, getting r successes, selecting R from N, that is selection process, you all know. Selecting R trials from N trials is NCR base. Probability of getting success, R times. Probability of getting failure, total number of trials are N, out of N R are success, failure are remaining, n minus r. So this is called probability function for binomial distribution for r successes. Probability of r successes is NCR P power r Q power n minus r. Here P is probability of success, Q is probability of failure, R is number of successes, N minus R are failure cases, failure trials. This is the probability function in binomial distribution. Using this probability function, one can easily evaluate, excuse me, one can easily evaluate probability of R successes. You may have one doubt here. When we have a standard formula for probability, favorable items by favorable events by number of events, total number of events, then what is the need of using these distributions? By taking one simple example, you can understand what is the need of these distributions. Here, take an example of tossing a coin. If there is one coin, you can easily calculate probability of getting tied, because two outcomes you will have. If there are two coins, sample space contains 2 square 4 elements, there also we can 3 items. With little bit difficult, we can find the probabilities for 1 head, 2 head, 3 heads, like that. For example, imagine if there are 5 coins, then number of elements in sample space are 2 power 5. 32 outcomes you need to write manually, then only you can calculate probability easily by counting favorable events and total number of events. Imagine writing 32 outcomes and selecting from that is how difficult. If it is 10 coins, 2 power 10, 1024 outcomes, how you can write? Is it difficult, right? There this distribution comes into picture, where that very difficult case can be calculated within a second. For tossing a coin, we all know that, for example, getting head we need, by assuming getting head is probability of success, getting tail is probability of failure. For one coin, what is the probability of success? Getting head, 1 by 2, we all know. Probability of failure, we all know, 1 by 2. P 1 by 2, Q 1 by 2. N is number of coins or number of times experiment conducted. If N is 10, probability of R success, probability of 1 head unit, you can easily calculate like this. If N is 10, the same coin is tossed 10 times or 10 coins are used. For tossing a coin, we all know that for tossing a coin, P is 1 by 2, Q is 1 by 2. So I need probability of getting exact 2 successes. Then how to calculate this one? Using this formula very easily you can calculate. R is 2, 10C2, 1 by 2 whole power 2, 1 by 2 whole power 10 minus 2, N minus R. You know how to calculate this value using calci, very easily you can calculate. That value is probability of getting exactly 2 heads. Like this, for any case you can calculate probability within a second, where the classical definition of probability takes much time, where the discrete probability distribution, preparing the discrete probability distribution is too difficult manually. In that cases, we go for binomial distribution. Next we will discuss what is mean of binomial distribution, what is variance of binomial distribution, how we are calculate median, mode, recurrence relation, everything we are going to discuss. Are you clear what is the use of distribution functions? There are so many applications for these distribution function, but here we are discussing these 3 distributions only. 2 discrete distributions, 1 continuous distributions. Any doubts you may ask? Mean and variance of binomial distribution. So here we are going to find what is mean of binomial distribution. What is variance of binomial distribution? We all know that in binomial distribution, probability of R successes is NCR P power R Q power n minus R. This we all know. So what is mean for this? Mean means you all know expectation of X, which is summation R equal to 0 to n R into P of R in terms of R. If you want, you can write in terms of X. X equal to 0 to n X into P of X. Because we learn this binomial distribution formula in terms of R, that's why I am preferring R here. So simply write in the place of P of R equal to 0 to n R into, in the place of P of R, NCR P power R Q power n minus R. Now expand this one by writing in the place of R0, 1, 2, so on n. If you write in the place of R0, 0 plus. If you write in the place of R1, 1 into NC1 P power 1 Q power n minus 1. Similarly, if you write in the place of R2, 2 into NC2 into P square into Q power n minus 2 plus so on plus. If you write in the place of Rn, in the place of Rn, n into NCn into P power n Q power n minus n Q power 0 1. If you write in the place of Rn, Q power n minus n Q power 0 1. So here few simple formulas which we learn, we have to recall, which already we learned in some other classes. NC1 is n, NC2 is n into n minus 1 by 2 factorial or 2 factorial is 2. NCn is 1. Similarly, NC0 is also 1, but we don't have NC0 here, that's why I didn't write that one. NCn. So if you replace that values, what you will get? NC1 is n P Q power n minus 1. NC2 is n into n minus 1 by 2 P square Q power n minus 2 plus so on plus NCn is 1 P power n. So here 2 get cancelled. If you observe, in every term you are having NP, 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 NP. So I am taking NP common. If you take NP common, what happens? Here you are having Q power n minus 1. NP common, you are having n minus 1 into P Q power n minus 2 plus so on plus NP common, n common, P also common. If you take P common, divide with P to get a term after common. P power n by P, P power n minus 1. So we all know the binomial distribution expansion. I am writing that one here. So this is a small rough work to understand what I am going to write next. We all know this binomial theorem. Binomial theorem. NC naught x power n. NC naught x power n. NC1 x power n minus 1 into y plus so on plus NCn y power n. So like this you will write it. NC naught x power n. You don't have y here. Y power 0. NC1 x power n minus 1 y power 1. NC2 x power n minus 2 y power 2. NC3 x power n minus 3 y cube, like that. x power decreases, y power increases. At the end, last term you won't find x, because x power n minus n 0. So if you write NC01 like that, x power n, NC1 is n, x power n minus 1 into y, plus so on, plus NCn is 1, y power n. So if you compare these two, what you are having? First term, power n minus 1. So here you are having n, here you are having n minus 1. Here you are having x, here you are having q. Here you are having p, here you are having y. The same term, but in the place of n, you are having n minus 1. Next n minus 2. Q power is decreasing, finally p power is increasing, finally p is power n minus 1. If you compare these two, what you will understand, in the place of x you are having q here, in the place of y you are having p. So what we can write that one? Q plus p, in the place of n you are having n minus 1, using binomial theorem. So we all know that in binomial distribution, p plus q is 1. So p plus q is 1, 1 power anything is 1. So 1 you will get mean of binomial distribution is this one. Next, coming to the variance. Variance of binomial distribution. We all know that variance has formula expectation of x square minus expectation of x whole square. What is expectation of x square? So in terms of r, we can write like this: expectation of r square minus expectation of r whole square. If you write this one as r, expectation of r. So expectation of r square means summation r equal to 0 to n r square into p of r minus expectation of r whole square means expectation of r is np. So and we all know that probability of r is NCR p power r q power n minus r. Or we can write this one in the next step. Before that, I am doing some small simplification here. I am subtracting r and adding r for that to simplify easily. So then what you will get? Summation r equal to 0 to n. This r square minus r can be written as r into r minus 1 p of r. The remaining I am writing plus summation r equal to 0 to n r into p of r. This one into this one. R into p of r separately I written. Minus n square p square. So we all know that this summation r into p of r is expectation of r. Expectation of r. That's value is p np. So this is expectation of r, which is mean. It has value np. So I am going to write there np. Now I am replacing p of r with NCR p power r q power n minus r. Simply I am adding and subtracting r to simplify easily. And this can be written now as np. Now write in the place of r 0, 1, 2, 3 as previous derivation. Write in the place of r0, you will get 0. Write in the place of r1, 0. 1 minus 1, 0. Write in the place of r2, 2 into 2 minus 1 into nc2 p square q power n minus 2. Write in the place of r2. If you write in the place of r3, 3 into 3 minus 1 into nc3 into p cube q power n minus 3 plus so on plus Finally, write in the place of Rn. If you write in the place of Rn, n into n minus 1, p power n, q power 0. Q power n minus n, q power 0, 1. So the leftover term plus np minus n square p square. Now coming to here, 2 minus 1 is 1 and nc2 we know n into n minus 1 by 2. nc3 is n into n minus 1 into n minus 2 by 3 factorial. 3 factorial means 3 into 2 into 1, 6. So here 2, nc2 is n into n minus 1 by 2 p square q power n minus 2. 3 into 3 minus 1, 2. 3 2s are 6. nc3 n into n minus 1 into n minus 2 by 3 factorial. 3 factorial again 6. pq q power n minus 3 plus so on plus n into n minus 1 into p power n plus np minus n square p square. So here 2 2 get cancelled, 6 6 get cancelled. What we can take as common? So if you observe, we can take n into n minus 1 into p square as common. N into n minus 1 p square, n into n minus 1 p square will have like that till n. So I am taking n into n minus 1 into p square as common. Then what you will have? Q power n minus 2 plus n minus 2 into p q power n minus 3 plus so on plus n into n minus 1 common. P square if you take common, p power n by p square, p power n minus 2 you will have plus np minus n square p square. So now compare this one with this. If you compare these two, so in the place of n you are having n minus 2. In the place of q you are having x. In the place of p you are having y. Same expansion, similar binomial expansion only. This is x plus y whole power n, but here in the place of n you are having n minus 2. In the place of y you are having p. In the place of x q plus p whole power n minus 2 plus np minus n square p square. We all know that q plus p is 1, that value becomes 1. In binomial distribution, q plus p is 1. So now what you are having here, this one only, multiply this one, n into n square minus n, this one multiply n square p square minus np square. If you multiply these three, n into n square p square, n into 1 n, np square plus np minus n square p square. So plus n square p square minus n square p square get cancelled. Now what is left over term? np minus np square. If you take np common, what you will have? 1 minus p. From p plus q equal to 1, what we can say about 1 minus p? In binomial p plus q is 1. So q can be written as 1 minus p. So in the place of 1 minus p, we can write q. So variance of binomial distribution is npq. Variance is npq and mean is np. Mean of the binomial distribution is np. Variance of binomial distribution is npq. Any doubts you may express anywhere.